Yes, a mineral-filled transformer with a 13 kV primary installed outdoors does require a moat to contain the oil. The purpose of the moat, or oil containment system, is to prevent environmental contamination in the event of a transformer oil leak or rupture. Mineral oil, used as a coolant and insulation in transformers, can be harmful to the environment if released into the soil or water. Regulations typically mandate secondary containment for oil-filled equipment, especially in outdoor locations where spills can easily spread. The specific requirements for oil containment can vary depending on local and national regulations, such as those set by the Environmental Protection Agency or local environmental agencies. These regulations often specify the volume of oil that the containment system must be able to hold, which is typically equal to or greater than the total oil capacity of the transformer plus an allowance for precipitation, such as rain or snow. The moat is usually constructed of concrete or other impermeable materials and is designed to prevent oil from seeping into the ground. It may also include a drainage system to collect rainwater, which must be properly treated or disposed of according to environmental regulations. In addition to the moat, other containment methods can be used, such as synthetic liners, spill pads, or underground storage tanks. The choice of containment method depends on factors such as the size of the transformer, the location of the installation, and the specific environmental regulations that apply. Regular inspections of the transformer and the containment system are essential to ensure that they are in good working order. Inspections should include checking for leaks, cracks, or other signs of damage that could compromise the containment system's effectiveness. It is also important to have a spill response plan in place in the event of an oil leak or rupture. The plan should outline the steps to be taken to contain the spill, clean up the affected area, and report the incident to the appropriate authorities. Proper installation, maintenance, and monitoring of oil containment systems are crucial for protecting the environment and complying with regulations. Ignoring these requirements can result in significant fines and environmental damage. When designing an oil containment system, consider the following factors. Firstly, the volume of oil that the transformer contains. The containment system must be able to hold at least this amount, plus an additional allowance for precipitation. Secondly, the type of soil and groundwater conditions at the site. This will help determine the type of containment system that is most appropriate. Thirdly, the proximity of the transformer to sensitive environmental areas such as wetlands or waterways. This may require more stringent containment measures. Fourthly, the local and national environmental regulations that apply to oil-filled equipment. Fifthly, the accessibility of the containment system for inspection and maintenance. Sixthly, the cost of the containment system, including installation, maintenance, and disposal. Seventhly, the life expectancy of the transformer and the containment system. Eighthly, the potential for vandalism or accidental damage to the containment system. Ninthly, the climate and weather conditions at the site, including rainfall, snowfall, and temperature extremes. Tenthly, the availability of emergency response services in the event of a spill. Furthermore, it's crucial to understand the relevant codes and standards. For instance, the National Electrical Code, or NEC, does not specifically address oil containment for transformers. However, it does cover general requirements for the installation and maintenance of electrical equipment, which may indirectly relate to oil containment. Other relevant standards may include those published by the Institute of Electrical and Electronics Engineers, or IEE, or the American Petroleum Institute, or API. These standards provide guidance on the design, construction, and operation of oil-filled equipment and containment systems. It is also important to consult with local authorities and environmental agencies to determine the specific requirements for oil containment in your area. They can provide guidance on the applicable regulations and best practices. When selecting a contractor to install an oil containment system, it is essential to choose one with experience and expertise in this area. The contractor should be familiar with the applicable regulations and standards and should have a proven track record of successful installations. It is also important to ensure that the contractor has the necessary insurance and licenses. In addition to the physical containment system, it is also important to implement a comprehensive spill prevention control and countermeasure, or a SPCC plan. The SPCC plan outlines the procedures for preventing oil spills, controlling spills if they occur, and cleaning up spills after they happen. The SPCC plan should be tailored to the specific facility and should address all potential sources of oil spills. The SPCC plan should also include training for employees on spill prevention and response procedures. Regular drills and exercises should be conducted to ensure that employees are familiar with the plan and can effectively respond to a spill. Proper oil containment is not only a legal requirement but also a responsible environmental practice. By implementing effective oil containment measures, you can protect the environment and prevent costly cleanup efforts. The financial implications of not having proper containment can be significant. Cleanup costs for oil spills can be substantial, and fines for environmental violations can be even higher. In addition, the cost of replacing contaminated soil or water can be prohibitive. Therefore, investing in proper oil containment is a wise financial decision in the long run. Consider the environmental benefits of oil containment. Mineral oil can contaminate soil and water, harming plants, animals, and human health. By preventing oil spills, you can protect these valuable resources and help to preserve the environment for future generations. Furthermore, think about the safety benefits of oil containment. Oil spills can create slip and fall hazards, and they can also pose a fire risk. By containing oil spills, you can reduce the risk of accidents and injuries. Furthermore, always consult with qualified professionals to ensure that your oil containment system meets all applicable requirements. Electrical engineers, environmental consultants, and regulatory experts can provide valuable guidance on the design, installation, and maintenance of oil containment systems.